In 2.2, we're going to organize quantitative data. So we have a scenario where a pair of dice is rolled 30 times, and the table below gives the sum of each of those rolls. So on the first roll, the sum was 8. Now that could have been a 4 and a 4, it could have been a 3 and a 5, it could have been a 2 and a 6. We don't know. We just know what the sum of the roll was. Okay, so we can create a relative frequency table, and this is discrete data because it's countable. Unlike the continuous data, remember with the weights where it could be within a range, you might not have exactly 2 or exactly 3. You could have 2 1/2, 2 1/3, so on and so forth. So anyway, this is discrete data, and this is a relative frequency table. So we've got all the possibilities of sums. The lowest sum that you can have when you roll a pair of dice is 2, and the highest you can have is 12, and we have everything in between. And then we take a look at the frequency of the rolls. So only one roll gave us a 2, and so then we divide that by 30 because there were 30 rolls, and so we can see that the relative frequency was 0.0334. Okay, and then you can do that for all of the rest of those trials. So we want to create a histogram for the discrete data. The first thing we need to do is draw your x and y axes, and then we're going to label the x-axis with each of the outcomes. So that's going to be your 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 for each of the sums of the rolls. And then your y-axis, is going to be the relative frequency or the frequency, okay? Just like we did with the qualitative data. And then for histograms, your bars have equal width, but they touch each other. And so that's one of the big differences between a histogram and a bar graph. Bar graphs tend to represent qualitative data, where histograms are quantitative data. Okay, so our bars, again, they both have equal width in both bar graphs and histograms, but in histograms, the bars touch each other. So where one bar ends, the next bar starts. And then again, just like the bar graphs, the height of the bar is going to represent either the frequency or the relative frequency depending on which type of graph you are constructing. So here's our histogram from that table of data that we had from the scenario. And so there you can see that the bars are touching. Notice that the center of the bar is the number, the sum of the dice. Okay, so where the bar for 2 and the bar for 3 meet is halfway in between, so it's at 2.5. And so then the bars for 3 and 4 meet at 3.5, and the bars for 4 and 5 meet at 4.5, and so on. And so this is the frequency. Notice that you don't have any halves because you can't get a half of a roll of dice. So all of the bars end up at whole numbers. All right, so now we have another scenario, and we're looking at mortgage interest rates from 30 randomly selected applicants, and this is for one specific period of time. So these are all the different interest rates that those applicants were offered. Okay, and so we want to now look at continuous data because all those mortgage rates, they're not whole numbers. They have all of those the decimals in between. And so when looking at continuous data, you're going to find a class width by taking the largest data value and subtracting the smallest data value, and then divide by the number of classes that you want. Okay, and so you always want to keep it between 5 and 20 classes. And basically the classes is going to tell you how many bars you're going to have for your for your histogram. Okay, so you're going to take the largest data value and subtract the smallest data value. So notice if we go back, our largest data value is 8.3, and the smallest data value is 3.7. So you're going to take 8.3 minus 3.7, and then divide by however many classes that you want. All right, so let's take a look at our relative frequency table. So in this case, we're going to have 6 classes, just because that made the most sense. And because that also allows us to make each class between, like, all of the mortgage rates that are 3 point something. and then the next class will be 4 point something, and then the next class will be 5 point something. So that just made it nice and clean. If we had tried to divide by 5, we would have gotten some messy decimals. Same thing with 7 or 8. And so this just made it a nice organized way to create our classes. So that's something else that you want to think about when you're trying to determine the class width. You want to try to make it a nice, neat interval. That'll just make it easier for when you go to graph it. Okay, so then we have our class widths. We have our classes. Sorry, the class width is one whole unit. So then we go back to our table and we look at how many are between 3 and 3.99. There were 2. How many were between 4 and 4.99? There were 12, and so on. And we knew that there were a total of 30. So we can find the relative frequency just by dividing each of those frequencies by 30. And that gives us the percentage of mortgage rates that were offered between those two numbers. All right, so then what we can do is we can create our histogram. Now, we're going to learn how to do this by hand in class, but you can also use technology when we look at StatCrunch, which we'll use in class. We can also use the graphing calculator, and we'll talk about that in class as well. All right, so when we create our histogram, again, the center of your bar, each bar, is the middle of that class. Okay, so the center of this bar is the first bar is going to be about 3.5. So the beginning of the bar is at 3, and the end of the bar is at 3.99. And so then the beginning of the next one is 4. So they're backed right up to each other. They're touching. And so then you can just draw the heights. So I would always start with, drawing my X and Y axes, but then labeling my X axis and making sure that the width of my classes is the same, because remember, we want our bars to be the same width. If you change the size of the bars or the width of the bars, that's going to skew your data, and we'll talk about that in the next section. But anyway, so you want your class widths to be the same, and they need to be touching each other. So it might be easier to label your x-axis first, and before you start drawing bars or anything. And then also determine how you want to label your y-axis. Sometimes it might make more sense to go by 1s, 2s, 3s, 5s, however you want to label that. That's up to you. But just make sure that it's clear and that they are evenly spaced. All right, so the next kind of graph we're going to look at is called a stem and leaf plot. And this is nice because it allows you to see each individual data piece, and this is the same data from the mortgage, the interest rates. And so you'll notice if we turned it 90 degrees counterclockwise, you would notice that it has the same shape. If we were to draw a line over top of those numbers, it has the same shape as the histogram that we had drawn. So this allows us to see not just the shape like the histogram does, but it allows us to see every single piece of data within that plot. So it just gives you a little more information. But you'll notice that the numbers on the left-hand side before the line, those are our whole numbers. And this is going to vary depending on what your data is like. Sometimes that'll be like the tens unit. Or it could be hundreds. Well, there might be two numbers there and it'll be 100 units, hundreds and tens. It really just depends on the data, and we'll talk more about that in class. But in this particular case, that line is where the decimal point is. So the left-hand side is the whole number, the unit, and then the right-hand side is the tenths, the number that's right after the decimal point. Typically, we try to put them in order so that way it's easy to see what kind of data we have. All right, so here are our distribution shapes, and I talked a little bit about shape when we were comparing the histogram and the stem and leaf plot. But the first one that we see is called uniform. It's symmetric. That basically just means that the frequency is the same for all of the categories or all of the classes. And then in the upper right-hand corner, that's your bell-shaped. That's symmetric also. But we also call that the normal curve because it starts out pretty small, it increases, and then it reaches a peak and then comes down. And it's pretty symmetric. You could take the center and fold it in half vertically, and if you drew a vertical line down the center and folded it in half, it would line pretty closely up to itself. And then in the bottom left-hand side, that one is called skew to the right because it's kind of like the bell-shaped, but it's got that long tail off to the right-hand side. And so the tallest point is shifted over to the left a little bit. So that's skewed to the right, wherever the tail is, that's the direction of the skew. And then if you take a look at the one on the bottom right, that one is called skew to the left because you'll notice the tail is off to the left and the highest point is shifted over to the right a little bit.